Okay, so now the first question, solve for n. Listen, if you are good with equations and you don't do them in your head and you go through step by step the process of doing inverses, then you will find this particular question to be pretty easy. Solve for n. The most important part of what I just said is for n. When you read solve for n, what is that telling you to do? Get n by itself. In this case, we always attack the plus or minus first. Remember, if I had a 2x plus 1 equals 7, my first step would be to minus the 1. So now I'm going to plus the y. Prendergast, I think you minus the y. Was that a mental spasm or a misunderstanding?
Mental spasm.
Okay, these things happen. I have plenty myself. Kn equals rs plus y. Is the n all by itself yet? No. Why is it not by itself? Everybody? Because of the k. And the k next to it means what operation?
Multiplication.
So you need to divide. So I divide by k, and I get n equals rs plus y over k. Any questions? No. Okay. So when it comes to these fractional equations, up until now, the technique that I have taught you, I refer to as the blood and guts technique. You are now going to learn the smooth technique, the polished technique, if you will. Back in the medieval times, or a little after the medieval times, they would go out in armor and they would swing these big, heavy weapons to try to pierce right through the armor and just hack it to pieces. And then the French came along and they made the rapier. The rapier was the long, thin sword that they go, and they could just stab in the vulnerable points of the armor. And it was so quick that in some ways it was a more effective weapon than the more intimidating looking sword. What do you notice about all of these terms? They are fractions. I would love to get rid of the denominators. Wouldn't that be cool? If we get rid of all the denominators and make them look like normal numbers again? I can. And this is how I'm going to do it. I'm going to ask you, now this is really important, so don't deviate your attention. Me ahead in the game here. This is going to be using the least common denominator in a way that you have never used it before. Most of the time, with a least common denominator, as in the blood and guts approach, you're constantly trying to combine things to get least common denominators. Now I'm going to figure out what that least common denominator is, but I'm going to use it in a way that's never been used in your lives up until now. What's the least common denominator of all of those terms? 4, 3, 2, and 12. What's the least common denominator? Everybody? 12. Because 4 goes into 12, 3 goes into 12, 2 goes into 12, and 6 goes into 12. So what I'm going to do is I'm going to multiply the entire equation by 12. That's not the 12th power. I'm multiplying by 12, and I'm going to multiply everything by 12. Isn't that allowed with an equation? Right? As long as I do the same thing to both sides, that scale stays balanced. Isn't it true? Okay. Now, for purposes of now, because I think it's a little easier to understand, I'm going to be very methodical about how I write this out. All I'm going to do is put a 12 in front of every term. 12 times 3/4 x minus 12 times 2/3 equals 12 times 5/2 minus 12 times 5/12 x. Okay? I think it might be a really good idea to write that down. Yeah. Yeah, it's a brand new technique, very powerful technique. Extremely good technique. And it will make Wyatt's paper legible.
Nah, I doubt it.
Oh no, I don't. Do not doubt it. It'll do it. Has everybody copied that down? Now, this is the first thing you had to pay attention to was the fact that you're using the least common denominator in a brand new way. Did you notice that I didn't at all try to make the denominators the same? Did you notice that? All I did was use the denominator to distribute it to all of the terms. Now, watch what happens. This is pretty cool. Ready? 4 goes into 12 3 times. 3 goes into 12 4 times. 2 goes into 12 6 times. 12 goes into 12 once. Now just multiply what's left. 3 times 3x is 9x. 4 times 2 is 8. 6 times 5 is 30. 1 times 5x is negative 5.
That is negative.
I'm sorry?
Yeah.
Negative.
Well.
Right. And now it's just a regular opposite side, opposite operation situation. So I'm going to add 5x to both sides. And I get 14x plus 8 equals 30. Then I'm gonna, why did I get plus? Oh, this was a minus. That's what you were talking about.
Yeah.
I'm sorry. So this is a minus, so this is a plus 8. I copied that wrong, obviously. 14x is 38. Divide by 14. And I get 38 over 14, and that happens to reduce to 19 over 7. Okay? Yes?
Why didn't we learn this one first?
Because I fear with parentheses and distributing. Because then you would be distributing to something you would distribute, and I think I would confuse you. So if you notice, I chose an equation that didn't have parentheses. The ones on your quiz last time all look like this. 2/7 times 3/5 x. And I was afraid that if I distributed to distributeds, I would confuse you. So I wanted to show you blood and guts first. And also, Sarah, the truth is that a handful of kids won't get this. And they will get this. So for those kids, they can do it the way we just did it on the quiz. And then for the other kids who think this is tedious and methodical, they'll go with this technique. But my experience says that if I have 42 kids in the two classes, out of the 42 kids, probably 35 will do it this way, but 7 will still do it this way. So I want to make sure everybody gets a chance to see it, and then you can choose whichever technique you like the most. So just make sure that you realize you're taking the least common denominator, you're distributing it to all of the terms. This is the key to it all. Listen, look at me. Don't multiply it. A lot of kids will go like, they'll multiply it, get this, multiply it, get that, multiply. No. Just write a 12 next to everything. That's all you need to do. And then reduce them. And then you always get a step that looks like this with no more denominators.
What if you forget? What if you use the wrong column?
Then you're gonna get it wrong. So, yeah, right, and that's it. You may be one of the people who goes with the other technique, and maybe that's why they do it. Okay, and it doesn't make you bad. This is a better technique. It's cleaner. But the other way works too, and you know, that's just the way the world works. Go ahead.
What about the negative signs? What happens to them? Like, it would be negative 12 and then 5 over 12 in parentheses, right?
Yeah, but when I do 12 into 12, I get 1, and then negative 1 times 5 is negative 5, and then the x.
Okay.
So you just treat them the same way you've always treated them. Don't change anything. Over here, 3 goes into 12 4 times, minus 4. Times 2, minus 8. You won't, using this technique, you will never change a sign just because you're distributing that number across. All right, any questions? All right, so that's a very powerful technique, and it is a great technique. And the further along you go in math, the more you will use that technique. On your quizzes, I would suggest for now that you try to use that technique even if you hate it, and give it a little working, and then after this series of quizzes, go with whatever you like the most. All right, now, this one. This was the one question on the test that I felt like saying to certain people, what are you thinking?
I guess.
What are you thinking? Look, it says A what?
Minus.
Minus B. So in other words, it's 3x squared plus 5x minus 4 minus negative 2x squared minus 9x plus 7. That's a 9. 9x plus 7. What do you do when you see the minus in front of the package again? Change everything. Look, you have to understand, B is this whole thing. So you're subtracting the whole thing. And this, by the way, is right off a Regents exam. I'm starting to incorporate some Regents exam questions. Whenever you see print like this or font like this, it means it came straight off a Regents exam. Now, the next step is always the step where you show every sign being changed. So this is 2x squared plus 9x minus 7. And then 3x squared plus 2x squared is 5x squared. 5x plus 9x is 14x. And negative 4 and negative 7 is negative 11. You know what's funny? The first 5 or 6 papers I graded all got this one wrong. And they all put choice 2. And choice 2 is the answer if you add them. If you don't change the signs. So the key step is to change the signs. I keep coming back to it. On the last series of quizzes, I said the same thing. You've got to be ready to change the signs on these questions. All right? Any questions at all? All right. So, you know, obviously I'm making the video right now, and if you need to, you can look it over when you get home. But I also think that this is a very doable sort of thing. All right. So let's take a look now at another one where it says to solve for y. When you read that phrase, solve for y, what does that mean for you?
Get y alone.
Get y by itself. Excellent. So I'm going to subtract 3. I'm going to subtract 3 x's from both sides. That's a minus sign. I don't know why it came out that way. 5h minus 3x equals 2y. Then I'm going to divide by 2. Divide by 2. Hopefully the pen will catch up in a second. Maybe not. Divide by 2. And I get 5h minus 3x over 2. That needs to be a routine question. That needs to be when you look at a question like that, you're like, oh yeah, make the whole test like that. Those are the easiest things going, okay? Now, the next question is going to get into what today's lesson is about. Consider the equations x minus 2 equals 6 minus x, and x minus 2 squared equals 6 minus x squared. So we're going to think about that a little bit. Did squaring both sides affect the solution sets? So I'm going to solve this one. And you know what? I'm going to do it really quick in my head. Adding x to both sides is 2x. Adding 2 is 8. Dividing by 2 is 4. That's the answer to that one. Everybody get 4?
Yeah.
Okay. What's that?
Isn't it negative 2?
Yeah, but I'm going to add 2 to both sides. That makes 8.
Oh, you
And then add the x is 2x. So 2x is 8. X is 4. Now, if I do x minus 2 squared equals 6 minus x squared, what's going to happen here? Well, this is an interesting thing. What do they mean by x minus 2 squared?
After you do that equation, you have to square it.
You have to do x minus 2 times x minus 2, right? Isn't that what it means to square? So that means you got to kind of go off on the side here and do double distribute. If you prefer box method, you can do that. But if I double distribute, I distribute the x to both of them. That's x squared minus 2x. Now I distribute the negative 2 to both of them, and I get negative 2x plus 4. So altogether, I get x squared minus 4x plus 4. Now I need to double distribute 6 minus x squared. And I'm going to get 6 minus x times 6 minus x. Distribute the 6, distribute the negative x. What's 6 times 6? 36. What's 6 times negative x? Negative 6x. What's negative x times 6? Negative 6x. And what's negative x times negative x? Positive x squared. So altogether, this is 36 minus 12x plus x squared. Now, when you first look at this, you're probably saying to yourselves, I don't like this. There's x squareds in equations. And with those x squareds in there, I don't know if I can get this right. However, no need to panic. Just subtract x squared from both sides. And I get negative 4x plus 4 equals 36 minus 12x. Okay? And then it's just a matter of solving. I'm going to add 12x to both sides. And I get 8x plus 4 equals 36. And then I minus 4. And I get 8x is 32. And I divide by 8. And I still get that x is equal to 4. So the truth of the matter is, that when we have a regular linear equation, which is what this is, and then I take the same exact things, which are what they are, right? And I square them, you still come out with the same answer. It's not going to affect it. It's not going to create a whole new answer for you, all right? This lesson is titled Deepening Equation Understanding. So what we're understanding is if I have a scale, and at the end of the scale I get 4 equals 4, then when I square both sides, isn't the scale still going to stay balanced? Because I'm doing the same thing to both sides? In this case, I still did the same thing to both sides. Because I did the same thing to both sides, I'm okay. All right, number 3 is a lot like questions we've been doing the last few days. 5 times x to the 0. I did have to work with a couple of people with extra help on cleaning this up. The x is to the 0, not the 5. So when I plug in a 2, 2 to the 0 is 1. Then I multiply that by 5 and I get 5. So it's not 1. The 0 exponent only applies to the x. It does not apply to the 5. If I wanted it to apply to the 5, I would have to put it in parentheses. And then x to the negative 3, negative exponent means reciprocal, so this becomes 5 and 1/8. Okay? Any questions? Okay. Your turn to play a little. Try number 1. A, B, and C. You don't have to actually write out the x squared stuff and everything. You just have to check the answers from A, B, and C and follow along. Okay. So we look at the first equation. I hope you verified that 3 works to both equations, right? Are you with me on that? Okay, so I know the directions seem awkward because you haven't seen them before, but they're not complicated. If I plug in a 3, isn't 3 plus 1 4? And if I plug in a 3 here, isn't 3 plus 1 4? And if you square 4, you get 16? Okay, here's the thing that I want you to understand. Remember how when we graph parabolas, we said that the zeros, which are also called roots, which are the answers to the question, are wherever it crosses the x-axis with the parabola, right? How many answers did you have usually when the parabola crossed the x-axis? 2, right? Aren't there usually 2 roots? Not always, but usually there were 2 roots, especially on the questions I designed. See, if it's a squared exponent, there are 2 answers. What do you think there would be if the exponent was 3? 3 answers. What if 4? 4 answers. Here the exponent is 1. We don't even write it. So there's only 1 answer. The next question says find the second solution. And there normally is. There's not always, but there normally is. The second solution is negative 5. The reason negative 5 works, let's substitute it in here. What's negative 5 plus 1? And what's negative 4 squared, which means negative 4 times negative 4? 16. So it does check. So you have to be aware that when you square both sides, the original answer still works. But, it's a big but. The big but here is when you square it, right? When you square it, there's 2 answers. So you gotta start thinking, maybe there's another answer, or there could be 2 answers, okay? Based on your result, what effect does squaring both sides of the equation appear to have on the solution sense? When you square both sides, you don't only have 1 answer anymore. What can you have? 2. Now, it's not guaranteed that you'll have 2. Let's be clear about that. But you can get more answers when you square both sides. And that would be the point behind the question. Okay, consider the equation x plus 4 equals 3x plus 2. Show that adding x plus 2 to both sides of the equation does not change the solution set. So this is what you're going to do. First, solve x plus 4 equals 2. What do you come up with? If you want, do it in your head. X plus 4 equals 3x plus 2. What's the answer? What do we get?
6.
No. Well, what are we going to get? Quiet?
1.
1 is right. If I subtract x from both sides, I'm going to get 2x over here. If I subtract 2 from both sides, I get 2. So that means that x is 1. Okay, now, starting with x plus 4 and also 3x plus 2, what we want you to do is add x plus 2 to both sides. In other words, you're going to add the same thing to both sides. Now, solve that equation and show that x still works out to be 1. Okay. We still come out with an answer of 1, don't we? Right? Is everybody getting that? Right? Get confirmation? Everybody getting that? All right, let's look at what the next one says. The next one says, show that multiplying by x plus 2. All right, if you work on that one at home, you'll see that x equals negative 2 also works. Okay, folks, hasta la vista, vaya con Dios, toodaloo, coffee in a minute down in the cafeteria. Let me just stop the recording here.